Hello, how are you?
I'm doing good. What about you?
Can I ask you to increase your microphone volume or?
Sure. Okay. Hello. Am I audible now?
A little bit more if you can.
Okay. Hello. Am I audible now?
Yes, thank you. So using artificial intelligence everywhere in the field is sometimes we face ourselves limited to the hardware that we have to carry. But as we all know, by now we have a lot of processing power in our pocket, and I am giving you the room to talk about how to use machine learning on Android platform.
Sure. Hi everyone. And today, as you just mentioned in brief, as the host just mentioned in brief, we'll be talking about how you can superpower your Android apps with machine learning. So, if you if you haven't used machine learning in Android earlier, haven't deployed machine learning to edge devices earlier, no problem. I'll walk you through it, and you will make your first Android app. Oh, sorry. Let me do something. Okay. Hello. Okay. So let me know if my voice is clear now.
It is, thank you.
Okay. Uh, Sorry, I had a bit of mic fluctuations. So now I guess it should be clear. Uh, okay, I'll start back again. So today we'll be talking about how you can superpower your Android apps and deploy the machine learning models you have made in your Android applications. So if you haven't used machine learning in Android earlier, haven't deployed machine learning models to edge devices earlier, no problem. I'll walk you through it, and you will make your first Android app today with machine learning deployed, or deploying machine learning models. If you have worked with machine learning in Android earlier, have worked with earlier versions of Android, know about the TF Lite Android support library, then I'll show you better ways to do it with Android 11. So let's get started. Hi everyone, I'm Rishit, and before we start, I've switched on captions from my end, so it would possibly be easier for you all. You'll see them down on these slides. Okay. Hi everyone, I'm Rishit, and a bit about me. I'm currently a high school student from India. I'm also a TEDx and TED speaker. And a part of the things listed down over here, I've often represented my country in international competitions and hackathons, and even won a few. I further love research, so I've published 7 research papers in the field of machine learning and mathematics. Feel free to give them a look and know more about me. All of my coordinates are at rishit.tech. Feel free to give that website a look. And my socials are also here. If you want to do any discussion, I'm open to it. Okay, so let's get started. So before I start uh, with today's topic, machine learning on edge, how to deploy them in Android applications, I would like to thank Syed Paul, who's a machine learning GD, Khan Leviat from Google, and Hoy Lam from Google, who have helped me in reviewing these slides and putting together a better version of these slides. So let me just tell you a bit about who the ideal audience would be for this talk. It would essentially be folks who have worked on deep learning models. So if you have made a deep learning model earlier, be it Keras or or TensorFlow estimator using TensorFlow estimator high level APIs, it does not matter. You should have made a deep learning model earlier, or a machine learning model as you might call it. And developers who are looking for ways to put the machine learning model into a production ready manner. So, well, if you have made a machine learning model, it's not much useful unless it's actually out to the users. So if you want to deploy your machine learning models on Android, this is the right talk you have come to. Okay, so first off, why care about ML in Android? So I'll not talk much about this, so we can get to the cool stuff very quick. But I'm sure all of you know how the number of Android devices have increased exponentially. I'll be giving you no numbers. I already know all of you are aware about how the number of Android devices have increased exponentially, and are probably also aware of how machine learning is revolutionizing almost every industry. So it makes sense to make this power of ML available to everyone. And how do you do that? Well, you deploy them on mobile devices. We already use products like Google Photos, Gboards, Prisma. You maybe also use Gmail, and it's due to ML that these are so powerful. So about I told you about why you should care about ML in Android, but today a prime concern would be on-device ML in Android. So today we are majorly going to talk about on-device ML due to some reasons, which we'll soon see. And Android 11 has a lot of cool stuff, has a lot of cool new stuff for on-device ML. Most of the developments are related to on-device ML. So let's take a look into what this hype about on-device ML or ML on edge is all about. The idea is to use ML such that, opposed to the traditional approach, I no longer send my data to a server or a cloud-based system, which then does the ML and then returns me the outputs. I instead get the outputs or inferences from my ML model on the device itself. That is, I no longer send data to a cloud-based system or some server in general. This also means I do all the pre-processing stuff, data preparation stuff, the inference stuff in the mobile device itself. I don't send it outside the mobile device. Okay, so coming back to the question, some of you might be wondering, okay, Rishit, you told me what on-device ML is all about, but you still didn't tell me why should I care about this. So let's come to that. Why is this something you should care about? So the first thing that would come to your mind is power consumption. I spend a lot of power sending or streaming my data continuously to a server, and sometimes it becomes just infeasible to do so. If you're sending a high quality video stream continuously to a server and receiving inferences from it, it would it might take up a lot of power. So yeah, it's something you should be considering. But yeah, also worth a mention. This is not true in all cases. If you have some heavy pre-processing steps, it could happen that the pre-processing steps take up more power than sending to a server and receiving the data. But in most of the cases, this is something you might care about. Another important thing to consider, especially in real-time applications, is the time it takes me to get the output or essentially run the model. So I want to decrease my inference time as much as possible. I want my users to see uh, almost no latency or do not have much visible latency. So, well, have if you do the ML on the device itself, you are decreasing the inference time. And this is also expensive in terms of network availability. I guess you might have already figured this out by now. This is if you are doing some real-time application, sending some video to a server, getting the inferences back, it's pretty network expensive. And I should have the bandwidth or the network to continuously send the data and receive inferences from the server. And finally, another thing which I would like to highlight is maybe you also figured this out, security or privacy, as you may call it. I no longer send data to a server or cloud-based system. I, in fact, no longer send data out of my device itself. So, what does that mean? I essentially enforce privacy. there are a couple of more steps you would do, a couple of more things you would do, but yeah, but this enforces privacy since you're not sending data out of the device. So that was about why you should be caring about on-device ML. So now let us see what Android 11 has for you to do all what we discussed. That is performing on-device ML, pre-processing, doing the inference itself, everything. One of the most coolest updates with Android 11 is the ML model binding plugin, or the machine learning model binding plugin, as you may call it. And before I move forward, uh, I would just like you to make a good enough guess from the name model binding. So you can make a fair enough guess from the name model binding that what would the model binding plugin do. And yeah, also you need Android Studio 4.1 or above to be using the ML model binding plugin. So the ML model binding plugin makes it super easy for you to use a TensorFlow model in your Android app. You essentially have a lot less code to write that calls you TensorFlow Lite Android support library. So for folks who have already been using TF Lite Android support library earlier, you will find this super easy. It will just make your writing the code stuff a lot less, and you are going to love this. For the folks who have not used the TF Lite Android support library, no problem. You will see how you can deploy ML models on Edge. You can import TF Lite, or you can import a TF Lite model, read the input output signatures of the model, and use it with just a few lines of code. And you also don't have to convert everything to byte arrays explicitly. So if you have used TF Lite on Android devices earlier, you know that earlier you had to explicitly convert everything to byte arrays. You no longer have to do that with the M model binding plugin. Another another thing which I love about the model binding plugin is it makes it very easy to enable hardware acceleration or make use of GPUs and the neural network API very easily. With the model binding plugin, let's say I want to enable GPU acceleration with the model binding plugin. It's just a dependency call and a single line of code away. So if you want to enable GPU acceleration, it's just one line of code you have to add. Isn't that super cool? And you can also do much more with the neural network API in terms of hardware acceleration, and the model binding plugin makes it easy. And of course, with all what we talked about, this will make your development a lot more faster. We just talked about the features you have, the support you have for integrating your models, and this would make your development a lot more faster. You essentially write a lot less code. So let's see how to do this in practice, and we'll also go through an example of it. So the first step, of course, is to import the TensorFlow Lite model with metadata. So Android Studio now has this new option for importing TensorFlow models. Just right click on the module you want to import the model in. So once you right click on the module you want to import your model in, you will now see a new option called TensorFlow Lite model. So once you click on the TensorFlow Lite model, it will give you a window looking something like this, and you can just pass in the path of your TF Lite model. It will import the model for you in a directory in the module called ML. So it will make a directory in the module where you have imported the TF Lite model called ML, and that's where your model will be imported. This will also be the path from where you will be using your model. So I don't know if you can see it clearly in the slide, but under the place where I can write the path of my model, I have a checkbox called automatically add TensorFlow Lite GPU dependencies. So yeah, adding the GPU dependencies is also just a click away over here. So now from my model metadata, so remember me telling you that you would be importing your TensorFlow Lite models with metadata. So once you open your TensorFlow Lite model in Android Studio, in most cases it will be just double clicking on the TensorFlow Lite model. You'll see the metadata. Right? So here you can see a couple of important things which you need to use the model. So you'll see the input output types, the input output shapes, the license under which the model is made, and so on. A description of the model, the architecture which the model uses, if the publisher has made it available, and so on. So a couple of important things in the model metadata, which you can also see in Android Studio now. So in this screenshot, I'm using, okay, so I'm making an example in this talk. So what we can do with this is, this will be applicable to other models, but we'll try to deploy a simple model. So yeah, we make something cool while I do the talk. So we'll make something together in the talk, and it will be applicable for the models too. So in this screenshot, I'm using an open source model made by me to classify between rock, papers, and scissors. Oh, rock, papers, and scissors. Yeah. So I just show the camera rock, papers, or scissors, and it should tell me whether I have put a rock, paper, or scissor in front of it. That's the model I've made. And yeah, again, it's well applicable to other models, but we are just taking an example. So we build something while I do the task. So that's about the model I'm importing. And and in the rest of the session, I'll be calling this model the RPS model, as the name suggests. I'll be using that acronym. Okay, so we imported my TensorFlow Lite model. Let's finally start using the model. So what we'll do now is we'll make something for a streaming inference, which is most probably what you want to do, live image classification, and we'll make an example of it too. So the easiest way to do this would be to essentially use camera X and pass each frame, so each frame from my live video input to a function which can perform the inference. So I'm using camera X, taking in my live video input, parsing each frame from it, passing each of these frames to a function. So in this talk, what I'm interested about is this function which actually does the inference. So let's see how you do the inference, and you'll also see how easy it is to do this. A sample code for this is also seen when you import a TF Lite model, which you can use. So first off, I'll start by instantiating a RPS model, or a rock, paper, scissors model, which I just imported, and pass it with the context. With the plugin, my model name was rps model.tflite. That is my model file name, rps model.tflite. So once I import it with the model binding plugin, what it will do for me is it will create an exact same class name called RPS model. So a class of the exact same name would be made for you. So as you can see, you're in this slide too, I have a class called RPS model, and I'm simply instantiating that class. So I'm simply making an object of that class and passing in the context. Once you do this, you need to convert your data into a form which we can use. So we'll convert it into a tensor image. And how would we do that? We'll do this from a bitmap and pass in an image proxy to it. So folks who have used TensorFlow interpreter before, you know that at this stage, you explicitly needed to convert everything to byte arrays. Well, you no longer need to do that. That is all abstracted for you. And I'll simply feed in the image proxy and convert it into a tensor image. So I can use it with my model. So now I have converted my data into a form which is usable by my model. What next? Well, I'll do the inference itself. So let's pass in the data and do the inference. So you can see some code over here. Don't get intimidated by this. We'll take this line by line. So first off, I process the image from my model, which is essentially saying, okay, take this image and give me the inference or the output for this. So I'm passing in the TF image we made just on the line above this and get the outputs from the model. So if you see, these are what we'll get from this is essentially an array of probabilities. So I had three labels in this: rock, papers, and scissors. So I'll get an array with length of 3 with the probabilities for each of these classes. And then I'll perform a descending sort on it. So descending sort is just some filler over here because in this application we are creating, we need the user to see the label which has the highest probability. In some, maybe in some application, I don't know why, but maybe you want to do something like show the label which has the least probability. We'll just do an ascending sort, or show show the label which has some other kind of probability, do some calculations. Well, it is all up to you. It's just a simple array. You can do anything you want to do. But in this case, to make things simple, I've just performed a descending sort on it. So saying the label which has the most accurate, which has the most probability, will be the first one, and so on. After this, I also pick the first end results to show. So in this case, I have rock, paper, scissors, just three labels. I can show them all to the user. But let's say you are working on more of a real world scenario and you have a model with 1000 labels. Well, if you use well, you don't want to show the user all of these labels. I just want to show the user top few labels. So yeah, I'm just doing a dot take and picking the top few labels. After this, I want to show the labels finally to the user. I've performed the inference. I've done some sorting and some processing on the outputs. So it can be as I want to show to the user. I'll add the label corresponding to each entry in the outputs and then show it to the user. And that's pretty much what you need. Just a few lines of code over here, and you did the inference and pretty much you did the inference, took in the data, did live did live inference, and this is how easy the model binding plugin makes it. As you can see over here, just a couple of lines of code. So remember me telling you how easy it is to enable hardware acceleration. So let's say in this example itself, I want to use GPU acceleration. So I had told you one line of code and one dependency call. So let's see that. So I want to use GPU acceleration. So what I'll be doing is I'll make an options where I specify to use GPU. So I'm saying model.device.gpu and I'll build it. In the instantiation part of the model, what I'll just do is I'll pass in this options, a part of the context as an argument. And there it is. You can use the GPU now. So the model binding plugin also makes it very easy for you to use a neural network API for acceleration and to do even more with Android 11. And with Android 11, you have a lot of cool updates to the neural network API, like asymmetric int8 weights and a new quality of service API, which just allows you to do a lot more. But I'll leave that for some other talk as I'm running out of time now. So let's talk about the other major development, which is a new ML kit. So I guess a lot of folks here know about MLKit, know about the earlier version of MLKit. But if you don't know about MLKit, I'll just give you a quick brief. So MLKit provides state-of-the-art pre-trained models available for you to use right in your Android apps. It has a couple of uh, a couple a couple of services which you can use. These are some of the services. This year we also have a couple of new services like pose detection and digital link recognition, and some changes to the existing services which we'll come to. So these are the services you can do very easily with MLK. So before I move on, MLKit is now available even without having to make a Firebase project. So remember earlier, we used to make a Firebase project and then use MLKit. Well, now MLKit is available to use even without a Firebase project. As I said earlier, a lot of these updates are focused on device ML due to the benefits we just talked about. The new ML kit now has better usability for on-device ML. You can do a lot more about on-device ML with the new ML kit. The ML kit image classification and the object detection and tracking now also support custom models, which means you can have just a TF Lite model along with the state-of-the-art pre-trained models. So you can specify a custom TF Lite model, make it run on top of the state-of-the-art pre-trained models by MLKit, and that allows you to get a better customizability. So yeah, that's also something cool with the new MLKit. As of now, this is supported only for the image classification and the object detection and tracking models with MLKit. What this also means is if you're working on some generic use case, let's say a specific kind of image classification, you don't need to make a fully blown model right from the data collection to the training to the deploying part. You can just use MLKit. So let's say I'm doing a particular kind of image classification. I can make a TF Lite model and run it on top of the MLKit image classification model. And it's and MLKit is which makes MLKit the best thing to use if you're working on some generic kind of use case, as I mentioned an example just now. So let's see an example and let's see how to use MLKit in practice. So again, we'll be building something while I give this talk. So this is applicable for other kind of models too, job models too, but we'll be seeing an example. So we build something while I'm doing this talk. So here I build so here my goal is to build an application which can classify different food items. So I'll first start off by setting the model and specifying the TF Lite model file for it. So this is the TF Lite model file I've made which works as a food classifier. And yeah, it should be added as an asset before you do this step. Say if you want or you want it to be loaded properly, it should be an asset. It should be added as an asset in Android Studio. So yeah, I've set off my model and specified my TF Lite model file for it. This TF Lite model will run on top of the object detection and tracking model with MLKit. So you can customize these options a bit, but you'll not get complete customizability as well. Your model is running on top of another state-of-the-art pre-trained model. So with MLKit, you can customize these options a bit. I have a couple of options to show you as an example of customizing options with MLKit. So first off, I specified the dot set detector mode. So I'm just telling it, okay, I want to use stream mode, which is live image classification, doing all of this in a streaming mode. Another example I've shown over here is the confidence threshold. So I'm saying 80% is my confidence threshold. You can try switching around the confidence threshold, see how it works around. But yeah, I can customize these options a bit. So let's get to the part where we actually run the model. Again, don't get intimidated by code. You might see some syntax similar to the previous example here. First off, I process my image, which is essentially doing the same thing, getting inferences. I process my image, and then I have some listeners over here. So, which is saying if I have a non failure listener, I want to print out something to the debug log. If I have a success listener, so if it is success, my model has seen something from the live video input that okay, this is a food. I want to I want to draw it on the graphics overlay. So that is what I'm doing in the on success listener. And once it is complete, once all of this is complete for a single frame, I want to close my image proxy. So that's essentially what I'm doing. Three cases I'm failing, the model is failing, the model has success in classifying what is there on the video input screen, and once it is complete. So another thing to note over here is all of these are essentially listeners. So that is on failure or on success are essentially uh, okay. So these on failure on success listeners are essentially tasks. So you need to attach them for every run. So that is something you would keep in mind, that you need to attach them for every run because these are essentially tasks. And that is pretty much you need to do uh, to work with MLKit and uh, and run a TF flight model on top of it. Again, pretty easy, just a few lines of code. So we talked a lot about what to do after you have a TF flight model. We talked about deploying it using machine learning model binding plugin, MLKit. But let me talk a bit about the TF flight model itself. So I'll not talk much about these as these are a bit out of scope, but you can make state-of-the-art models with TF Flight Model Maker. You can use state-of-the-art models with TF Flight Model Maker. It's high performance, super easy to use, super easy to get started with TF Flight Model Maker, and allows high customization too. And yeah, this was also released by the TensorFlow team this year itself. So the models I've made, the rock paper scissors model I demoed in this talk was made with the TF Flight model maker itself. So give it a try. And yeah, sample examples of using the TF Flight model maker are also present in the repository for this talk, a repository which I made specially for this talk. I'll be sharing that soon with you. So you can try out examples from that too. Another place where you can find good models is TensorFlow Hub. You can find state-of-the-art, well-documented models on TensorFlow Hub. And remember, we just made a food classification app, an example food classification app. So the TF Flight model, the food classification TF Flight model, was taken from TensorFlow Hub. So you can definitely give it a try. And you also get to use models from the community with TensorFlow Hub. So these are not just the only publishers on TensorFlow Hub, but these are the only ones I could fit in a single slide. So you get to use models from the community. I also have a couple of models on TensorFlow Hub. Be sure to check them out. Okay, so enough of talking. Let's get to demos. So here is the GitHub repo for this talk. It has everything which we talked about today implemented. It also has the source code, which I used to create the TensorFlow Lite models. You can take a look at them, and we'll also see a live demo of this. So I'll wait for a minute while you take a screenshot of this or take a note of this URL. What I'll also do is maybe paste it in the chat. Okay. So take a note of this URL. This would, if there's one thing you want to look back to after the talk, it would be this URL. Okay, I've pasted it right here in the chat. You can take it from the chat too. Yeah. So let me quickly switch my screen. Okay. Could you bring up my screen? Okay, good. Uh, so let, let me show you a bit about the model binding plugin, which we just talked about. As I'm a bit out of time, I'll be showing demos for one of the things we made in the talk. So let's talk about the ML model binding plugin. First off, I instantiate my model, pass in the context. What I then do is I create a tensor image. So, and how do I create that? I create that from an image proxy. So I create a tensor image from the image proxy. I then want to get the outputs. So I use the dot process, the TF image we just made on the line above it. I sort it by descending, as I just told you in the slides, and take the top few results from it. Once this is done, I add the output labels and the output scores so I can show them to the user. Okay, so we we talked about we talked about MLKit, but I let's see a live demo of this. Let's see a live demo. So let's hope my keyboard can make a good background. It's pretty much one color, so shouldn't be a problem. Let's put something in front of this. Uh, well, I'm running this demo on my mobile phone right now. Let's put something in front of it. A rock. Let me take it a bit up. Okay, let's see. It tells me, well, it's a rock by around 70 to 80% probability, which is pretty good. Pretty good work that my model has done. So that was a live demo of what we just made, and yeah, I'll again switch my screen. So yeah, I could have showed a demo in an um, EVD, but what's better than a than showing a demo on a live stream when it's available? So that's about my talk, all all what I had to present. And with that, if I have time, I would love to take some questions if there are.
Thank you very much, Rishit. That was very interesting. And I just have to say, the TensorFlow Lite as a tool is quite energy effective and is quite fast if you run it on a proper device that supports it. And we have to remember that today there are more IRM and IRM powered computers than every other computer combined. So they are basically the platform for something like that. But you also have to remember that TF Lite doesn't support all the operations of TensorFlow, right? And which means that not all the things you might want to implement on TensorFlow will be applicable to Tensor Lite on a mobile phone. Could you please tell us your opinion on what kind of tasks would be applicable to implement with TensorFlow Lite, and what kind of task you think that wouldn't fit?
Oh, so that's actually a great point highlighted by Bilal here. Um, you should know that not all operations on TensorFlow are supported by TensorFlow Lite, and they are constantly working on adding new operations. But let's say you have an operation with TensorFlow which is not supported by TensorFlow Lite, you'd essentially have to do something like make the operation from scratch on your own. That worked for me one time. I was trying some unsupported operation. I just uh, ma- I just made it into smaller operations which were already supported by TensorFlow Lite, and that could work. But yeah, you would need to know that a lot of operations are not yet supported.
And what do you think, like, what kind of models would be your first choice to switch to TensorFlow Lite? What kinds of applications, like
Oh,
real life applications of AI?
yeah. So one of the things that I think works best with TensorFlow Lite and has the most support is image models. So if you see the model binding plugin has wonderful support for image models now. I am not very sure about other kinds of models, uh, but yeah, the model binding plugin and MLKit have wonderful support for image models. TensorFlow Lite 2 has a great number of things you need for convolutional networks, uh, supported operations for it. So I think to start with, one of the best applications of AI on mobile with TF Lite would be image models.
Okay, thank you very much.
Thank you.
Now, I just have to know that Rishit is still a student of Narayana School. Am I pronouncing it right? Narayana?
Yeah, that's right.
Yeah, and he's already had given speeches to TEDx, and just I wish you good luck, and thank you for our support of the community event.
Thank you. It was my
Have a good
pleasure.
time.
And if you have any more questions, feel free to reach out to me on Twitter, LinkedIn, anywhere you find me. Thank you.
Thank you.